Sawadee Krap and welcome to another very short lesson here. Today it's about IT class, Introduction to IT. And today we talked about Object-Oriented Programming, OOP. And that's what this class now will be about, OOP, Object-Oriented Programming. This class, of course, will not replace the course that you could take at the uni. It's more like a short, again, a review of what you might have learned and just to develop an understanding of what OOP is about and why it is cool. Yeah, it really is cool. Why it is cool and what are the cool things about it. The important part when it comes to OOP is that OOP is a style. It's a philosophy. It is, for a better look, not a technology. It's not a technology. It's a style. It's a programming philosophy. It is not a technology. That's very important to know and very important to remember. So please make sure you remember that. And then let's dive a little bit deeper into what OOP really is. As the name suggests, OOP, Object-Oriented Programming. OOP is a lot about objects. Object-oriented programming. And now to figure out what is an object, we have a deeper look here. That's an example of an object. An object can be anything. Your car, your table, your dog, your sister, your brother, your desk, your iPod, whatever. In this case, we have the object student. I just say I define a student. And then you will add data to this object in order to define it. So we add data to this object. Example, it would be a student name that I didn't write down yet. Student name, the ID, we have the address, the course that he takes, ICT 101. That's all data that defines the object. That's important. We have the object and data that defines the object. Furthermore, we have classes. Classes. Those classes, let me add this quickly. Those classes, they tell us what the object can do. What the object can do is being told by classes. Classes define that. How do they define that? They define it via methods. You can see here, we have the class student. Say the student draws a graph, studies hard. Important here is that we always start with the class, the name of the class. Then we will open angle brackets. Then we will insert methods, called methods. And then we will close it with angle brackets. And that's how we define a class. And this class tells us what the object student that we defined earlier with data can do. Object can then have many more classes that define it. But for now, this is how a class works and why we have classes in order to define objects. So let's talk a little bit more about classes. Classes are very important to define what an object does. So let's just have a quick and brief look on classes. So at first, we can see classes, they are like a plan. They tell us what's going to happen, what things do. What does the object do, defined by classes. Now there are different kinds of classes. First class, the superclass. The superclass, and then we have the subclass. Superclass and subclass. Now what does this mean? I think it's the easiest to see on an example. The superclass is quite general. It describes something in general, like the car. And the subclass then goes more into detail. Like in this case, the Mercedes. The car, the general description, and then the Mercedes, very specific, very precise. That's the difference between superclass and subclass. Another example would be superclass person, subclass doctor, or then even psychiatrist, a subclass of doctor. It's getting more and more specific, from general to specific. That's very important when it comes to classes, superclass, subclass, and remember that the class is something like a plan, like a blueprint for something. So much for classes. Almost done for today. There's one little thing that I want to mention, and then we're good and we'll repeat it. The last thing that I would like to talk about for today are the 4 main principles of object-oriented programming. OOP is based on 4 main principles, very important principles, and those principles namely are encapsulation, abstraction, inheritance, and polymorphism. Now, since I said I only want to mention one more thing, lucky you, we will briefly talk about only one of those 4 principles, and we'll tackle the rest in the next lesson. This is now encapsulation that we start off with. And what does encapsulation mean? Encapsulation, last slide, means information hiding. What does now information hiding mean? Information hiding means we create our classes, but we don't show how they are created. We simply make them usable. What does that mean? It means we create our class, example, the class superteacher, fill it with methods like awesome classes, close it, and then we have it created. We have it in our repository and we could use it. But now, when we want to use it later on during our programming process, we will not copy everything that's here. We will simply reference it here and then can use it. That's pretty awesome. This means every time I want to use the class superteacher, which will be quite often because the teacher is awesome, every time I want to use the class superteacher, I don't need to copy everything. I simply have to put in one reference to this class and then can use it. That's one of the very, very good things when it comes to OOP, object-oriented programming. It will save a lot of redundancies. It's easy to maintain and very, very slim and hence fast to understand and to create. It's one of the best parts in object-oriented programming. And if there are any questions, raise your hand. Feel free to send emails or anything. We will briefly repeat what we did so far, and then you're already done for today. Congratulations. Final review, object-oriented programming. It's a style, it's not a technology, style or philosophy, not a technology. We use objects and classes. Those classes then later get divided into superclasses and subclasses. Objects are filled with data, attributes. Classes are filled with methods and tell us what objects can do. Then we have super and subclasses. Finally, we talked about the 4 main principles of object-oriented programming of OOP, which namely are encapsulation, abstraction, inheritance, and polymorphism. Encapsulation then means information hiding. Like we talked about a few seconds ago, we create our class, and later when we want to use it, we don't have to copy everything, we just reference it. That's one of the beauties of object-oriented programming. So far, well done. I hope you all understood what object-oriented programming is about. We will go a little more into detail and talk about the remaining 4 parts in the next video. So far, shoot your messages to my Facebook page or here on the channel. I try to reply to everything. Good luck and hope to see you around. Sawadee Krap.